Thank you, Benjamin. Hello again. My name is Marzie. I'm a PhD candidate in Climate Change Research Center, UNSW. And my research focuses on urban heat adaptation and mitigation using remote sensing and crowdsourced observational data. More specifically, I'm trying to investigate the role of urban land cover, background climate, and seasonality in urban heat at both local and global scales. During this presentation, I will talk about the first two projects of my PhD that have been completed, and also the direction of the last project that we have been doing. The first project was about understanding the role of background climate in surface temperature variability and how it affects urban land cover. In this project, we explored 54 cities among the top populated cities around the world located in different climate groups: tropical, arid, temperate, and cold climate. We used landsat imagery and remote sensing techniques to characterize different land covers and their impact on land surface temperature. We also tried to determine which variables contribute the most to intra-urban surface temperature variability in each climate group. Our results show that urban surface characteristics and their thermal response are significantly different in different climate classes, especially for arid cities. It also shows that in tropical, temperate, and cold climate, built-up index is the strongest contributor to surface temperature variability, whereas bareness index is the most important factor in arid climate. Findings from this study are discussed in detail in this paper. I also have a poster presentation tomorrow for this project, so if you are interested, please come and visit my poster. And now about the second project. In the first project, we looked at how background climate is important, how seasonality is important, but in the second project, we explored the implication of land surface temperature compared to air temperature. There are many studies investigating heat mitigation strategies using satellite-derived land surface temperature, but we know that air temperature is more relevant for public health and human thermal comfort. Now the question is how applicable land surface temperature is compared to air temperature, how it differs from air temperature, and what are the controlling factors of their interaction. To answer these questions, we use an air temperature dataset in Sydney combined with satellite imagery and a metadata on urban landscape. For surface temperature, we use Landsat 8 images. This is one of the extracted LSD maps for Sydney in a cloud-free summer day. For extracting air temperature, we use crowdsourced weather station data. This map is showing the location of the net atmosphere stations across Sydney, around 800 stations. We also added local climate zone and geoscape data to investigate the impact of urban form and fabric. This is the local climate zone map for Sydney. We use another high-resolution data set that provides us with detailed information about 3D structure of the cities, the information that is not exactly available in local climate zone. Variables like building height, building fraction, sky view factor, or for example, these maps are showing building fraction and tree fraction in Sydney. Now I'm going to show you some of the results. First, we characterize surface and air temperature values in Sydney across different seasons. You can see the selected days here, 4 days per season. This plot can show that there is a greater seasonal variability in land surface temperature compared to air temperature. In warm days, you can see there is a big range for LSD, which means that surface temperature varies greatly within the city. But in cold days, there is no significant variability. Probably because in winter, sun is lower in the sky, so most surfaces are shaded, having similar temperature. And also you can see the ranges of surface and air temperature are very similar in cold days, whereas there is a significant difference between these two during summer and spring. It's because for land surface temperature, solar radiation is a dominant factor, especially at the time of capturing temperature data, 10 a.m. But for air temperature, we have materials in the urban environment that absorb heat and release it later, so we don't see that immediate effect of solar radiation on air temperature during summer. These distributions are important because it tells us for identifying hotspots and the most vulnerable regions in cities. Land surface temperature derived from satellites might help for winter, But for summer and during extreme heat, the distribution of hotspots can be quite different. After this, we calculated the difference between surface and air temperature at all measurement sites across Sydney. The color bar here is showing the temperature difference ranging from -7 to +38 degrees. During summer, the difference between surface and air temperature can vary widely, but in winter they are pretty close, pretty similar across the city. This difference tends to increase with increasing the distance of stations from the ocean. Because of the moderating influence of the ocean, coastal areas have more stable temperature pattern than inland regions. So, when developing heat mitigation strategies for cities like Sydney, not only seasonal variability is very important, but also distance from the ocean needs to be taken into account. In coastal areas, surface and air temperature might be close, might be similar, but they can be quite different in inland regions. Now I'm going to talk about the influence of urban formal fabric. I've shown you how air temperature differs from land surface temperature across different seasons. But if we divide the temperature data into different local climate zones, then we see a different pattern. This figure is showing the box plot distribution of surface and air temperature values for each day categorized by local climate zone, for built local climate zone and for natural ones. Here you can see the difference between surface and air temperature is higher in the built local climate zone, especially those classified as compact low-rise and large low-rise compared to the natural ones, the green ones. It highlights the importance of considering the specific characteristics of local climate zone in urban heat studies, especially when predicting air temperature actually based on satellite-derived land surface temperature. After this, we calculated the correlation between surface and air temperature. Here you can see there is a positive correlation in all days, but the proportion of variation in air temperature explained by surface temperature varies depending on the season. The elongated distribution of scatters in all summer days, but the concentrated patterns in winter days. So seasonal variability is important for the correlation between surface and air temperature. But it seems that this correlation is also affected by other factors beyond just seasonal changes. So to dive deeper into this, in the next step, first we categorize the temperature data based on local climate zone, and then we extracted the correlations. In this table, darker colors are showing the stronger relationship. Here we can see categorizing the stations based on the local climate zone results in a stronger relationship between surface and air temperature. And more importantly, these correlations tend to be stronger in less densely built up areas. It's probably because of the heat. For example, I can tell you some examples. For example, natural local climate zones show a stronger correlation compared to built local climate zones. Or among the built local climate zones, sparsely built and large low-rise mostly show a stronger correlation compared to open low-rise and compact low-rise. It's probably because of the heat exchange between the surface and atmosphere, which is more direct and less influenced by human-made structures in natural areas. So it shows that using land surface temperature as a direct proxy for the urban thermal environment might not always be appropriate, especially when focusing on the spatial pattern and in densely built up areas. Now about the importance of the features. Which variables contribute the most to intra-urban surface temperature variability? We extracted feature importance using a gradient boosting model for each day. Here we have only 6 days. During summer and relatively warm days in autumn, total built, road pass fraction, and building fraction have the largest contribution to surface temperature variability. But in winter and late autumn, the dominant explanatory factors change to tree fraction, followed by distance from the ocean and elevation. In spring, the impact of tree fraction and water fraction is more pronounced in explaining land surface temperature. We couldn't run the machine learning model for air temperature because there's not enough data for that, But we extracted the correlation between individual urban variables and air temperature, and in contrast to surface temperature, there is no significant seasonal variability for the impact of urban form and fabric on air temperature. So to conclude, surface and air temperature have very different characteristics, and their interaction varies depending on season or urban form. Now I'm going to give you an overview of what we have done so far and what is still missing. In the first project, we conducted a global study. We looked at those spatial variabilities, the underlying factors, but we only looked at surface temperature. In the second project, we went a bit deeper in only one city, but we expanded it into more information about air temperature and urban form and fabric. But we are still missing some parts of the picture, which is about temporal and diurnal variability of urban temperature. How surface and air temperature change over a longer period. So this is motivating the third project of my PhD, which is about understanding the temporal variation in surface and air temperature. This is again a global study, but this time with modest satellite with a coarser resolution. And in this project, we are trying to understand how important background climate and seasonality are in temporal and diurnal variation of surface and air temperature, and how it differs between urban and rural areas. And yeah, I'm happy to discuss this project further with you if you are interested. Thank you.
Thanks very much for this